I have a binomial times a binomial, so we're going to distribute everything. So 2 times 4 is 8. 2 times negative 3 is negative 6i. I times 4 is 4i. And then I times negative 3 is going to be, or 3i is negative 3i squared, just like when you have x times x is x squared, I times I is I squared. I know that I squared equals negative 1. So I'm going to really have 8. Negative 1 times negative 3 is plus 3. Negative 6i plus 4i is minus 2i. That's going to give me 11 minus 2i. Now we're going to talk about simplifying expressions. An expression is completely simplified when the radical is not a fraction. We're going to talk more about radicals later. We know that I is just square root of negative 1. That's a radical. The radical cannot be split. And the denominator does not contain any radicals. So even though I can't simplify 3 over 2, because I have the I down there, that's really the square root of negative 1. I can't leave it like that. So really, if I rewrite this, I could rewrite this as 3 divided by 2 square root of negative 1. To get rid of the square root of negative 1, if I multiply denominator and numerator by the square root of negative 1, square root of negative 1 times square root of negative 1 is just negative 1. So we get negative 2. And then we get 3 square roots of negative 1, which we could write down as 3i. And now I don't have a radical in the denominator anymore, and so it's simplified. When you multiply top and bottom by the same number, you haven't changed your fraction, you just changed how it looks. Another way you could do it is, instead of always rewriting it, is if you just remember I squared is negative 1, I could rewrite it as 3 over 2i and just multiply top and bottom by I, so I can get the I squared. This is probably how you're usually going to do it, but that's just another way. This shows you the math kind of behind it and why it works. So for 13, I got negative 4 fifths I. So I'm going to multiply top and bottom by I. So I'm going to get a negative 4i over 5i squared. I know I squared is negative 1. So that's like negative 4i over negative 5. And a negative divided by negative is a positive. So we're just going to get 4i divided by 5. Sometimes we're going to need to use something called a conjugate to help simplify expressions. A conjugate, we're going to do an example here. A plus b and a minus b are conjugates. It's the same binomial, but the signs are flipped in the middle. So all we're going to do is change middle sign. The reason that we do that is because if I have 2 plus I, if I just multiply top and bottom by I, I'm still going to have an I in the denominator. So I'm going to use my conjugate. I'm going to do 2 minus I. And if I do it to the bottom, I also have to do it to the top. And it's going to be something really, really cool. So that's going to give us 3 times 2 is 6 minus 3i. In the denominator, we're going to get 2 times 2 is 4 minus 2i from 2 times negative I. I times 2 is positive 2i. I times I is negative I squared. So up top in the numerator, I can't do anything. In the denominator, I can kind of simplify some stuff. That's going to become 0. I know I squared is negative 1. So that's going to become a negative 1. So we're going to have 6 minus 3i over 4 plus 1, which is 6 minus 3i over 5. And now I have no more i's in the denominator, so I know it's simplified. For 15, my conjugate would be 4 plus I.